All right, let's do one more inequality. As soon as I see that greater than sign, I know it's going to be a number line and test values. Yeses and nos. First, to find out the values that go on the number line, we have to solve the related equation 8 over x minus 1 equals x over x minus 3 minus 1. So to solve this equation, I want to make all the denominators the same. So I'm going to put in x minus 3 in the first fraction, numerator, denominator. I'm going to put in x minus 1 in the second fraction. Now this 1 has to also have the like denominator of everybody else. So I'm going to make this be x minus 3, x minus 1 like all the others. X minus 3, whoops, moved. All right, x minus 3, x minus 1. Once the denominators are the same, you can cancel them out and make yourself a new equation. So what I have here is, you know what, I'm going to save my distributing for the next step. And you'll see why in a second. This is where the mistakes usually happen, in this part that I'm about to do right now. Keep those eyes open over there, buddy. You're on the verge. You on the verge. Hold on, let me just do this one, complete this one thought real quick. This is where the mistakes usually happen because of the minus sign, and I've got these binomial times a binomial. I would highly recommend multiplying this out first. Okay, if I double distribute this ahead of time, then that's going to give me x squared minus x minus 3x plus 3. Okay, so that's going to become x squared minus 4x plus 3. I just combined my like terms to get the negative 4. Notice how I put that in parentheses, though, because I've got this negative sign out there that's going to need to be distributed. And many a student, Alec, come on, buddy. Many a student forgets to distribute that negative sign. So do what I did, FOIL it out, but put it in parentheses. So now I'm going to have 8x minus 24 is equal to x squared minus x squared plus 4x minus 3. Okay, so that'll give us 8x minus 24. I'm combining like terms. So the x squares cancel each other out because they're opposites. Negative x, positive 4x, that's 3x minus 3. So now I'm going to subtract 3x from both sides. So that's 5x minus 24 is equal to negative 3. Add the 24 to both sides. So that's 5x is equal to 21. So x is equal to 21 over 5. So 21/5 will definitely go on the number line. All right, but what else is going to go on the number line? So far we know that x equals 21, whoops. All right, that's going on the number line. In addition to that, though, any excluded values will also go on the number line. So looking at the x minus 1, I know that x cannot equal positive 1. Looking at the x minus 3, I know that x cannot equal positive 3. So these are the three values that belong on my number line. So let's do it. Okay, so by the way, 21/5 it might be useful to know what the decimal value of this is. All right, 21 divided by 5. So that's 4.2. All right, that just helps me place it properly on the number line. Okay, so I have 1, 3, and then I have 21/5, which is the same as 4.2. Excluded values are always graphed as open circles because open circles mean the value is excluded. On the other hand, the 21/5, sometimes this solution will be an open circle and sometimes it will be a closed circle. If I just had greater than, then that would be an open circle. But because I have greater than or equal to, we will graph it as a closed circle to include the points where the function is equal to both sides. All right, so 21/5 is an equal to value, so we want to include that with an open circle. So we have this. Now we're going to pick test values in each zone. To the left of 1, I could check 0. Between 1 and 3, I could try 2. Between 3 and 4.2, I could do 4, because 4.2 is a little bit over. I'm going to do 3.5, just for fun. All right, just to be clear that it doesn't have to be a whole number. It can be a decimal, so I'm going to do 3.5. Beyond 4.2 is 5, so I could do 5. So you don't have to use the exact values that I just used. You just need one value in each interval. So I'm going to use my calculator to help me test this out. Whoa, okay, now's a good time to chat, my people. This problem is strange looking. Notice how I have variables on both sides. Whenever I see variables on both sides, in order to know what to put in my calculator to help me evaluate, I am going to rewrite the inequality to have 0 on one side. So basically, I'm going to take this fraction and I'm going to subtract it from both sides in order to move it over to the left. I'm even going to take the -1 and I'm going to add that to both sides in order to move it to the left. So I'm taking both of these, I'm moving them over, and then they will change signs. So if you do that, here's what the new inequality would look like. For starters, I have the 8 over x minus 1 that didn't move. Now here comes the x over x minus 3. But now it's going to be minus x over x minus 3 because I subtracted this from both sides. Now here comes the -1, but now it's going to be plus 1 because I actually added it to both sides, so it became a plus 1. Okay, so this is an equivalent version of this inequality, but it's a version that has 0 on one side. So that makes it easy because I could now put this in my calculator and compare the results to 0. So that's what I suggest. I'm going to hit the table function. So that's 8 over x minus 1 minus x over x minus 3. And plus 1. Make sure your calculator is in Ask X mode. And now I'm evaluating the function at these 4 values. So 0 and 2. So I've already got 0. And now here's 2. So that's negative 7 and 11. Now I'm going to do 3.5 and 5. So that's negative 14 fifths and 1/2. All right, don't forget what I'm comparing to. Now that I rewrote the inequality, I am comparing to 0. Specifically, is the value greater than 0? All right, I'm not saying equal to because we've already dealt with that. 21 fifths is the only point where the function is equal to 0. So that's already been covered. Everything else is going to just be greater than, so not equal to. So that's why I'm just writing greater than. I mean, it doesn't hurt to put equal to. So greater than 0, greater than 0, greater than 0, greater than 0. Now this is easy to answer because negative numbers are less than 0 and positive numbers are always greater than 0. So this is a no, this is a yes, this is a no, and this is a yes. The yeses show us where the solutions are. So we have solutions between 1 and 3, and we have more solutions from 21 fifths to infinity. So the interval notation would be 1 to 3 union 21 fifths to infinity. All right, notice the parentheses and the bracket. All right, I use parentheses here because of the open circles, not included. I use the bracket whenever I have a closed circle because both of these mean including the endpoint. But this is the final answer.